Okay, I'm going to be doing a tutorial here on how to use Sawtooth software to field a choice-based conjoint survey and collect the data, download it from the web, and do all the analysis. So there's a few programs you're going to need to do this. You need Sawtooth's design file, the design program called the SSI Web. You'll also want to have the SMRT program, which is Sawtooth's analysis package. Have a web browser, have Excel open, and open up these two folders too. Go ahead and get a window open for where your design file, where all of your design files are at. So when I create my Sawtooth survey, it saves these to some file path. Just open that up because we're going to be coming back and forth to this a lot, so it's easier to just have it open. My study is called USAS. This was a survey for SUVs in America, so USA SUVs. And the other thing you want to have open is your downloads folder because we're going to download that data, so we can just drag it over. That'll be easier. Okay, so first thing, I want to start actually by saying how we posted the files for the survey, so how I got the survey on the web. So after you've finished designing your survey, you went up here, you clicked Field, and then you click Prepare for Web Upload. And when you do that, it's going to create the files we need to upload the survey to the web. I've already done it, so I'm just writing over this. And I'm running a couple programs at once here, so it's going to be a little slow. And that goes here. In your design folder, there's a web upload folder. These are all the files you're going to need to host your survey on the web and then access it later to get your data. Okay? So you sent me those, I posted them on the web, and then now people have taken the survey, so now we need to get the data from the survey. So you go to a web browser, and you want to go to your admin page. So the admin page is the same URL as your survey, except that the last bit is the admin page. So here you have your survey name. Mine was USAS, and then you have these 4 letters. The survey is the 4 letters LOGN. If you go to that, you'll go to your survey. So this was the beginning of my survey. If you go to ADMN for admin, that goes to your admin page. So you want to go there, you want to log on, and here you can see a quick summary of your data, who's taken your survey, and those kinds of things. All I want to do is just get the data, so I hit download data, and then download all data. From now on, I'm just going to keep all the data I can get. I'm going to filter it out later, so just go ahead and get everything. And I'm going to save it to my download file. So it's a .dat format. And now I'm done with the web browser. And you'll see it in my download folder. Here it is. What you need to do, this is really important, is bring that into that design file folder. So the design folder with all these other files, I have to put that data file in here. If I don't, Sawtooth won't recognize where the data is. So I got to put it there so now I can find it. Okay, so that's done. The data's in here. Now I'm back in Sawtooth, the design software, the SSI Web. And since that file is now in there, the data file's in there, I can export my data. So I'm going to export 2 versions. One is all of the data, just in a spreadsheet as a CSV file. The other is going to be just the choice data. Okay, so I'm going to start with all of the data. So export data, all data. And you want to put this, it automatically sends it to your design folder. I usually create another folder called analysis or whatever you want to call it, but I just make a new one because it's going to start generating, we're going to start making a few different files. So I just want to put them all in there. And I call mine, let's just call it all data. All data. All right. I want to have all my respondents. This probably looks like this when you first get it. And you can select this is every single question that was asked on my survey. If you want all of it, just select the 2 arrows and you can take them all. And if you don't want something, you can just send it back. But I want everything, so I'm going to take everything. And finally, I'd leave these just the way they are. Okay, so you can hit export, and it's going to generate this CSV file for me. And that's going to be all of my data that I have from my whole survey. You open it up and you can see in that analysis folder, here it is. This is a CSV of all my data. And what I'm going to do is I'm just going to open this really quickly in Excel just to kind of look at it so you can browse it and kind of see what it is. I have to go find it. It's in my Sawtooth folder, studies. I have a bunch of different studies here. Analysis, and it's a CSV, so see if we can find it. There it is. So it's a comma separated, so I gotta delimit as I import this with commas, and that'll put them all in the right cells. There we go. So here's all my information for my survey. Every row is a respondent, so this is the ID of each respondent. There's a bunch of things you can see here. You have like their start time and end time, the elapsed time in seconds, so you can see how long did people spend taking my survey. There's a bunch of things. Now this whole file, you're not going to really use this to do any of the conjoint analysis. When you're trying to find your beta estimates, that's not what this is going to be for. This file is useful just as a way to kind of check and review, to view all of your data and kind of preview it quickly. So you can do a few things. One, you can see these are all the random choice tasks. And one of the things you can do visually is just look at this and see if you see like all of the same number, if you see like all ones or all twos or something like that, that means that person was just going click, 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 and they were picking the same one every time. They weren't paying attention or they weren't really giving it their effort. This should look like a bunch of random numbers. So if it does, good. If not, then you can probably screen those people out because they probably weren't paying attention. So that's just a quick visual check. You can run through your respondents. It looks like mine are all pretty good. Maybe this guy was just going ones, but otherwise it's pretty good. You can also use this to kind of get some quick summary statistics off of your data. So I asked a bunch of demographic questions at the end. I have things about marriage and how many children you had and things like that. And so if I want to know something like, how many people who took my survey were men and how many were women, I have this gender question here, and 1 was male and 2 was female. And so I can use a very simple little function here in Excel called COUNTIF, and it's going to count if this statement equals true. So I'm going to say COUNTIF, select this range, and what I'm going to say, the statement, I have to put it in quotes. Statement is equals 2. So if this equals 2, count it. I got 41. So that means 41 of the people who took my survey were female, and how many were male? People who selected 1, 43. Okay, so I can pull off some quick statistics about the people who took my survey that way. So that's about all I want to use this file for, and I just wanted to show you that that's all I'm doing is looking at this CSV file. I'm just previewing that here in Excel. Okay, so you can use that. The other thing I want to do is the more significant portion of all the data is the choice questions. That's what we really care about. So we did all this for. So I need to get those choice questions out of the design folder here, the design software, in a format that the analysis package can understand. So you have to hit export data and this one right here, prepare CSV data files. And what it's going to do is it's going to prepare this file called a .cho file. And this is a file that it's for choice questions, so that's the CHO. And I'm going to have all my respondents again. If I want to filter them, I can do that later. So I'm just going to keep all my respondents and hit prepare. Once this is done, it's pretty quick. Now I'm done with the design software, so I can close out of this. I don't need this anymore. And everything from here on I'm going to be working with is I'm just working with this SMRT program, the analysis program. You'll see in your main design folder again, that's where that .cho file went. So there it is right there. And okay, so you can open up the Smart package, hit New, and I'm going to save this study in that same analysis folder that I've been working in. Just call it Study 1, Save. And it's important that you choose this, choice-based conjoint. That's what we've been doing. That's the type of data we have. Okay. And I'm going to import that data. So I want to import the CHO file. Import .cho file. I'm going to browse for it, and it's in my same study folder with all the other files. There it is. Open, import. Okay, there it goes. So I have 86 respondents. Okay, and what I want to do now is examine this choice data, and I want to run my logit model over this choice data and see what my betas are. So I go to Analysis, and I go to Compute Utilities. And here I'm going to set up all the settings I need for the model I want to run. So I want to run a logit model. I'm going to hit Settings, and there's a few options here for the model. First, you can choose to include or exclude respondents. If you look at the filter, you can. I'm going to get rid of people who weren't complete. So if you were incomplete, I don't want you in my survey. And my fixed task, the fixed choice task that I used this as a screener in my survey. So what I did was I made the second choice an obvious answer. Like choice 1 and 3 were just really terrible, and this one was very, very good. So if you were paying attention and you understood the task, you would have selected 2. Most people did, and so I'm going to screen out people who didn't. And I don't want to use them because chances are they didn't understand the task or they weren't paying attention to the survey. Okay, so that's all I'm going to screen. I'm not going to worry about waiting. Choice tasks, by default, it includes all of them, but if you want, you can get rid of or include certain questions. So I don't want to include the fixed choice task because I wasn't using that to get choice information. I was just using that to screen, so I don't want to have that. And if you look at that like we just showed you, you could browse through all that data. If you saw that people were at the end, sometimes people get tired in the survey, and after question 10 or 11, they just kind of zonk out and they just start hitting 1, 1, 1, 1, 1, or so if you see that, if you have evidence for that, then you could choose to say, I don't want to include the last 3 maybe because I think those aren't good. But I don't have any evidence towards that in my survey, so I'm going to include everything. And finally, you can choose what effects you want to model. So by default, it sets up the main effects. If you have any interaction that you think is interesting or something that you feel might be significant, you can choose to do so here, but I'm going to recommend the very first model you run, just run all the main effects the way they are, and that's all I'm going to run right now to show you this. Okay, last thing you need to do on advanced settings, you need to click this box, because that tells Sawtooth to export to me the variance matrix, the variance covariance matrix, and I'm going to need that later when I'm doing things like predicting share of my own product as I put it into the market. I'm going to need this so that I can calculate confidence intervals and do things like that. Okay, so I need that. Okay, compute. I'm going to just call this run 1, and it's running. So what it's doing is it's using that logit model that we've seen before, and it is maximizing the likelihood function. And in a little bit, it'll come up with my betas. The more data you have, the longer this takes. I'm also running Windows inside a Mac right now, so it's kind of running out of RAM. Okay, there it goes. All right, so it gives me this design report. It tells me a bunch of information, tells me about my betas. Here's my beta coefficients, there's the standard errors. It also tells me my gradient, my variance covariance matrix because I told it to. So everything we need is there. It also generates this folder. It automatically reports this out in the folder. So mine was in the analysis folder. There it is, study 1 utility report. This utility report is the same thing. It just prints it out as a text file. So I'm going to close this. I don't need this now. I'm just going to look at the text file. Okay. And there's a couple things right off the bat that you can look at that can really help you inform your design or give you some information about how people were filling out your survey. So one of the things you can do is look at these numbers right here. In my survey, I had 3 options. You had 3 choice options, and this is the percentage of times that they chose each of those options. So if they're all even, they're about 1/3 each, that means that people were evenly choosing between the 3, which means it indicates that people were actually considering all 3 options when they selected one. If you get one of these numbers it's much higher than the others, chances are that people were paying more attention to that one question for whatever reason. Maybe they just were only reading the first option, or if they weren't paying attention and they were just going 1, 1, 1, 1, they're choosing 1 every time, then you would see a much higher number there. So that's kind of a first check of evidence. Were people paying attention? Were people doing a good job of filling out my survey? It looks like they were in mine. There's a little more information here about, this is some of the information about convergence, that the model has reached a maximum. And then we have our coefficients. Now, rather than look at them here, what I'm going to do is I'm going to pull this file as a text file right now. I'm going to pull it into Excel so that each of these will be in an individual cell, and then I can do more things with them rather than just look at them here. So I'm going to open up my Excel, get a new file open. I'm going to import that text file, this utility report. And if you've never done this, if you drag and drop it in, it's a pain, because all it does is it looks like, whoops, I double clicked on it. If you drag it in, it's not very useful because everything comes in, and this is one cell with all these things. So what I want is these to be in all different cells. So two things you can do. You can either hit data and you can import it from a text and you can delimit this, or if you've just dragged it in like this, then you can select all of this and you can tell it to sort this, or text to columns. It'll take this text and it'll make them into individual columns by some delimiting thing. And what I have is spaces in between these, so I'm going to tell it to text to columns and delimit this using spaces. See how there's no spaces, they're all in one cell. If I hit space, it breaks them into cells for me. And so that's really convenient. So I'm going to have it do that for me. There it is. So now I have all of my individual things in individual numbers, all in individual cells, so I can use them. Much more useful for me now. Okay. So I'm gonna focus here in right now on just how to interpret these betas and what they mean. So in my survey, I had a bunch of different attributes here. This was for SUVs, and the first attribute was vehicle type. So this is a conventional vehicle, a hybrid, plug-in hybrids, and battery electric. Now you see there's 8 levels here, and I have 8 coefficients. And if you remember, only 7 of those coefficients were actually estimated, because the way this, for identification, the way the logit model works is you need to fix one of the betas to a point, and then all of the other ones are estimated relative to it. So typically we usually fix 1 to 0, and then we estimate everything relative to that. The way Sawtooth does its estimations is it estimates the model. It'll estimate like the first of them, so in this case the first 7. And then the last one, rather than this being fixed to 0, what it does is it says this is equal to the negative sum of all the other ones. Okay, so what that means is if you check this, if you take the sum of all of these, you'll get, so the negative of this, yeah, there it is, that's the negative of this. And it just does that so that all of the coefficients in one attribute add to 0. There's no particular reason to do that. It's just what Sawtooth does. So you should just keep in mind that the last beta coefficient on each of these attributes is not actually estimated. This is just a calculated number that Sawtooth has calculated. Likewise, the standard error for this term is calculated. It's the average of all the other standard errors. So if you can check that really quick by taking the average of all the other ones, and you'll see that it's 0.114. There it is. Okay, so that's what these coefficients are. That's what they mean, and that's what you get out of Sawtooth. If you wanted to look at what this would mean for making one 0, like a dummied out coefficient, the way we've done it in class, what you want to do is you just add this term to all the other ones, and you'll see the way it would have turned out that way. So if I take this and I say equals this plus -1 times this, I want to do that to every row, to every every coefficient. Now I've just shifted everything up by that amount, and so the information is all the same. You know, this relative to here, everything is the same as this. It's just everything's been shifted up so now that this equals 0. So in the way we've run the models, we would get something like this. Sawtooth just takes the whole thing and shifts it down so the last thing equals the negative sum of all these. So that's what you're looking at when you get your report out of Sawtooth. Now, what I want to do now is focus in on the variance-covariance matrix and what we can do with it. If you remember your first order condition, you need your gradient to be 0. And here I have pretty much all zeros for every coefficient, so that's good. That means I'm at least at a stationary point. And you also note here that there's 22 zeros here, but up here I have 28. Why is that? Well, exactly what I just said. We have only 22 coefficients were actually estimated. The last one, this one, this one, this one, this one, this one, and this one aren't estimated. Okay, so these betas, these zeros from the gradient, refer to only the first ones of each attribute. Okay, so that's why there's 22 of them. Now, if we look at this variance-covariance matrix, the way Sawtooth gives the results, unfortunately, the texting, the way the text wraps in this utility report, is it wraps the text up. So you have the first row is actually all of this. So it runs this way and it wraps the text over here, and then it hits and it wraps over again, so it hits here. So the first row is all this, and you have to re-sort this out, because it really, the matrix, really the first row is all of these. If you move these, that's my first row of the matrix. And what I need to do is move every one of these out so that I get a 22 by 22 matrix. And unfortunately, this is really a pain to do just by copying, cutting, and pasting. If you know MATLAB or R, or even if you write up a quick little, there's other cleverer ways to do this in Excel, but you need to manipulate all this data so it gets it into that 22 by 22 here, and then you can do more with it. So I'm going to use a little bit of movie magic and stop and start the video, and then you'll see it all resorted. Okay, I've reshaped the entire variance-covariance matrix, so now it looks like this, rather than having that kind of runoff of the lines. And I've also highlighted the diagonal of this whole matrix, so it's a big 22 by 22 in my case, because I have 22 betas. That's the size of this whole matrix. And if you look at this whole diagonal and you read off the square roots of all of these, you get this. These are the square roots of the diagonal. Okay, and I'm just showing you that to show you again that this is where this is the standard error of each of those coefficients. That's where this comes from. So I bring it up here. I can kind of compare it. I just want to take the values there. I can compare it to my standard errors here, and you can see that the first, all these standard errors here line up with these. So that's where these came from. And remember, this last one here was calculated by Sawtooth. It took like an average of these to get it. So that's not something that's going to come out of this. You'll see that after this 0.12, which is this one here, the next one you see is 0.08, which is this guy here. It skipped this because this, again, is calculated, not estimated. So you can use your variance-covariance matrix to kind of make that check. You're also going to need to use it when you do any type of simulation. So you will have to do that eventually to, say, if you want to, for example, calculate the share of your product, and you want to get a confidence interval on that share. You'll need that variance-covariance matrix to do that. Okay, so one more thing I want to show you before we're done here is a couple of, a linear approximation kind of model. So right here I have, in this model setup, I've got a beta for every single level of every attribute. So here's my first attribute, vehicle type. I have a beta for every vehicle type. Here's brand. I have a beta for every brand. Here's price. I have a beta for every single price range. And these are discrete betas. So this is saying this is the beta coefficient when my price is 20, or these are in thousands of dollars. So when my price is 20,000, and only when this is 20,000, that's my beta. And then when my price is 25,000, this is my beta. And I have 5 betas. So another way you could do this is to estimate, because this is a continuous variable, is you could estimate just one price beta, and that will be how your utility changes as you change price. And basically what that is a linear approximation of these betas. So here I have plotted, these are these 5 betas right here against your price. So as my price is going up, my betas go down. And it looks pretty linear. In fact, if I fit a quick line to this thing, I can add a quick trend line, and I can look at that equation. And I see there is some slope here. It's negative 0.067. Okay, so that's a pretty good fit. It looks pretty linear. So what I'm going to do instead now is go back into this SMRT program, and I'm going to estimate this linear model, where now just for the price attribute, I'm going to say I want to run price as a linear, as varying linearly with price. So I'm going to go back to analysis, compute utilities, settings, and where you can make that change is in here, this effects coding section. You hit effects. And what I want to do is make price linear. So I'm going to say this is the linear attributes. I want to make just price linear. But in order to do that, you need to tell Sawtooth what each of those level values are. You need to tell it that the X, in this case, is thousands of dollars, going from 20,000, 25, 30, 37, 50. I need to tell Sawtooth that, otherwise it doesn't know that right now. So I have to come in here and I have to find price, and I have to assign those values. So 20, 25, 30, 37, and 50. Okay. Those are the levels. I hit OK. Make sure my covariance matrix is on, and I'm going to compute it. And this one I'm just going to call run 2 because it's the second one. It's going to now run a model with a linear beta for price. Hopefully this won't take too long. And what I'm going to do is I'm going to show you that this slope here, this 0.6079, that's going to be the beta that comes out of this, because it's basically just a linear fit. And here it goes, and there's my report. So I can scroll down and look at this here. Here it is for price. My price beta now, rather than having 5 individual betas, I get just one, and it indeed is the same slope. It's 0.0678. Here you go, 0.067. All right, so that is the slope of this line. So there's a couple reasons you could do this. I mean, you could do it. Reasons why you might want to do this. One, it helps you with your standard errors. If you have fewer beta coefficients to estimate, you're going to get better standard errors, because basically you have a set amount of data that you have, and the more parameters that you're going to try to fit to that data, the harder it is to be certain about each parameter. Okay, so if a linear approximation seems like a good fit, then using that can help you with those standard errors. Now, I'd recommend that you run it this way. You run the model the first time with everything being discrete, plot them out, see if it looks linear. If it looks linear, then you can go back in and you can run that linear model in here. Okay? Now, what you can take away from all of this, if this is your pilot survey, what you can take away is a couple things. One, you can compute some confidence intervals. Do a quick computation of your confidence intervals and see how big is my standard error and what does that really mean. If I want to compute a lower and upper, all I'm going to do is take my coefficient and I'm going to add 2 times that standard error on one side, and on the other side I'm going to subtract 2 times that standard error. Oh, I'm sorry, I labeled these backwards. This is upper and this is lower. Okay. And I can look at this confidence interval for each beta, and I can see, how confident am I about this estimate. And if I just looking at this very quickly, it looks like I believe it's 0.26. My confidence interval, from a 95% confidence interval, goes from 0.05 to 0.47.
that encompasses these other effects here. And so I can't say I'm certain that this effect is any different from any of these. However, down here, these are all negative, and their confidence intervals don't ever pass 0, either do these. So I can say, okay, I'm pretty confident that this is different from these. And if I got more data, I'm sure this would go down some, and I would get even more confident on that. So you can look at that, and you can take these confidence intervals and plot them around the betas on each for each one of these, for each attribute. Plot your betas, plot them with some confidence intervals on them, and then take away from that and say, did I get enough data? Do I need to get more data or not to get those confidence intervals down? And the other thing you can do here is look at the size of these effects. These all look to be pretty good sized effects. Nothing is really all zeros. But if you did get all zeros, if these came out as like 0.001 or something like that for every one of these, then that indicates one of two things. It's either that this whole attribute actually isn't really important to people. So if you have all zeros, it's maybe this attribute isn't important in driving choice, so the effect is very small. It's 0. Or maybe it is important and people just didn't understand it or they didn't pay attention to it. Maybe in some way that you presented the information, the people taking your survey didn't pay attention to this attribute because they, either they didn't understand what it was, or it was maybe off center on the page, or the font was really small, or for any number of reasons. So if you get a small effect size, you get close to zeros, start asking those questions. Think about, was my information clear? Did they understand what the attribute was? Look at the feedback from comments. And if you think, I think it was very clear, and I think that it's 0 because it's just not important, then maybe you can cut that from your final survey. Maybe you can cut that whole attribute and say, save yourself some statistical power. You don't going to waste it on an attribute that's not really driving choice. Okay, so that's all I have for now. Hopefully that was informative. Hopefully that can give you everything you need to run your models, and good luck.